Jello geometry friends, this is Congruent Triangle Notes, and we're going to start with this fancy word CPCTC, CPCTC, CPCTC. Say that 5 times really fast, but what I'm saying is CPCTC, and what that stands for is corresponding parts of congruent triangles are congruent. Okay. Corresponding parts of congruent triangles are congruent. CPCTC. Now that's going to kind of be the main focus for this entire lesson. If you can understand that corresponding parts of congruent triangles are congruent, the lesson will be pretty easy. Basically what it says is things that match up in equal triangles are equal. Right? That's the English translation instead of the mathematical translation. So let's say we have this. We have triangle ABC and triangle DEF. ABC and DEF. And it says triangle ABC is congruent to triangle DEF. Now, a picture and a statement can tell us many things. You have to be able to go from the statement to the picture and the picture back to the statement. And I'll explain more in detail in a second here. So, if the picture is labeled like this, it also tells us a lot. Alright, so first let's start with the angles and let's look at this. Notice A and D are labeled the same, and notice A and D come first in my congruent statement. Alright, so that's a congruency statement, and angle A is congruent to angle D because they come first. Angle B comes second, angle E comes second, and as always, my markings are the same. So angle B is congruent to angle E, and then lastly C and F come last, so angle C is congruent to angle F. Now that's always going to be true. Now the same is even true for when we go and we talk about segments. So we have AB and DE. So what that means is AB is congruent to DE. Segment AB is congruent to segment DE or ED, however you want to say it. It names the same segment. Now you can even go further and say that BC is congruent to EF. BC, EF. BC is congruent to EF. Then lastly, and this is probably the trickiest one, first and last is AC, first and last is DF. And of course, if we look at our picture, they match up as well. So AC is congruent to DF. So when they say a picture is worth 1,000 words, well, in terms of congruency statement, a picture is worth 6 statements. 6 things we know is always true. We can tell it just from the statement, just from the congruency statement, or from the triangles. Either way, we can deduce all 6 of these pieces no matter what. Okay? Makes sense? Alright, let's try some examples. How are we going to apply this stuff? So, first example. I'm going to call this CAT and DOG. And I'm going to label it and ask you to write the congruency statement. So I'm going to label it like this. And I would ask you, hey, write me a congruency statement based on the picture. Alright. So, you look at who matches up. I usually like to start with just whatever. Triangle CAT. Doesn't matter what order you go in. If you go ACT, that's fine as well. TCA. You can start however you want. The second one is the important one because you have to make sure everybody matches up. Well, C has 1 marking, so in this triangle, D has 1 marking, so D has to come first. Then we have A second. Well, A is my right angle, O is my right angle, and then finally I got G. So triangle CAT is congruent to triangle DOG. When I grade your congruency statements, we're going to look to see that everything matches. And by default, if your angles match, notice your sides match. CA, DO. Between the right angle and the 1 tick mark is CA. Between the right angle and the 1 tick mark is DO. Alright, AT, right angle 2 tick mark. OG, right angle 2 tick mark. So that's another way to determine it as well. Alright, and then we're going to go B, E, A, R, S, And I'm going to go like this and try to trick you. And like this. And I say, write the congruency statement. So you go to start. Triangle BEA is congruent to triangle S. There's only 2 tick marks. Where do I go from here? Well, there's one thing we do know in this picture here, and that's we have vertical angles. And remember, vertical angles are always congruent. So we went from B to E in my first statement. So S, well, do you think we go SA or SR? Well, if we went B to E, so we went one angle mark to empty angle, we're going to go one angle mark to empty angle, so this is going to be R. And then lastly, A falls right into place, and A is congruent to A. So that matches up. So you got to be careful. Sometimes the picture's different, and you got to take your time and match up who's who. All right, now lastly, this time we don't give you a picture. Straight up say, given triangle GOB is congruent to triangle EAR, solve for X and Y. Alright, so we're looking for X and Y. And everything we need to know is in the statement. So let's take this. We got GO. So we know GO. And this is all segments, so there's no angles here. So we're just focused on segments. And we know GO matches with EA. So GO, EA, we can go ahead and set those two equal to one another. Now we notice it's all x's, so let's go ahead and solve. So I subtract 2x to get 10x, add 33 to get 40, divide by 10, and x is 4. Then over here, I got OB, so OB matches up with AR. Fortunately, I got AR right there. So 14y minus 12 equals AR, which is 16. So I'm going to add 12 to both sides, 14y, and when you add 12, we get 28, divide by 14, and y is 2. Now, after you solve for x, you can actually find any other piece. So I could ask you to find GO. So we would take GO, which is 2x plus 7, excuse me, and we'd substitute in our 4. So 2 times 4 plus 7, 8 plus 7 is 15. So we know GO is 15 units long. Alright, that's all I got. See you when I see you.